Hello students, welcome all of you in lecture number 14. This is lecture for B.Sc.TY students, semester 5th, and paper is linear algebra. So in previous lecture we have discussed on the quotient subspace. And we know about what is meant by subspace. So in book, in textbook, in problem, that means exercise, there is a one problem, one example, and I am taking that. What is that? Prove that the intersection of two subspaces of V is a subspace of V. So same theory which we have discussed in group theory and ring theory. So intersection of two subgroups is also subgroup. In this similar manner, there is a problem. Prove that the intersection of two subspaces of a V is a subspace of V. So we consider, let W1 and W2 be any subspace, any two subspace of V. V be the vector space and W1, W2 are any two subspace. Now we have to show that intersection of two subspace of the V is a subspace of V. So since it is clear that zero vector element, that means zero vector omega W1 and W2, right? So it is declare that W1 and W2 are two subspace of V. So these are subspace, means it has at least one element and they should not empty. So at least zero vector must be there, and therefore 0 belongs to W1, 0 belongs to W2. So their intersection not equal to empty set. So it has a some element. And we have to show that this intersection is subspace of V. And we know that definition of what is meant by subspace. Now I am going to show that. Let we take omega 1 and omega 2 be the any two element belonging to intersection. Now we know that this is not empty. Means it has some element. I take these two some elements, that is omega 1 and omega 2 belong to these. Now if omega 1 and omega 2 belonging to their intersection, means omega 1 belongs to W1 and omega 1 belonging to W2. Any doubt? Actually, one second, we take step by step. Suppose two element omega 1, omega 2 belonging to intersection and alpha beta any two element of the field F. Okay. So now this omega 1 belong to intersection, meaning is that this omega 1 belong to belong to W1 and this omega 1 belong to W2. Next take omega 2 belong to W1 intersection W2. So this omega 2 belongs to W1 and this omega 2 belongs to W2. Now what is given that? W1 is a subspace. And therefore this element omega 1 omega 2 belongs to W1. So alpha omega 1 plus beta omega 2 must belongs to W1, because here omega 1 omega 2 belong to capital W1. So after multiplying by alpha, this alpha beta belonging to the element of the field F. So this element again belong to W1. First class. Similarly, so W1 W2 belong, omega 1 omega 2 belong to W2. So alpha omega 2 plus omega 1 beta omega 2 belongs to W2. So this element belong to W1, this element belong to W2. So this element must belonging to their intersection. So alpha omega 1 plus beta omega 2 must belongs to W1 intersection W2. So if omega 1 omega 2 belonging to W1 W2 and this sum is again belonging to W1 W2, meaning is that by according to definition W1 W2 intersection is a vector subspace of vector V. Hence intersection is a subspace of vector space V. So it is very trivial example. May ask in the exam. So it is important. So you prepare it, try to read it. So student, note one thing is that union of, now we have discussed about intersection of two subspaces. So intersection of two subspaces of a vector space is definitely subspace. But what about union? So see here, union of two subspaces. The union of two subspaces may not be subspace of any vector space V which depend on the field F. So intersection of two subspaces, definitely subspaces. But what about the union of two subspaces? So union of two subspaces may or may not be subspace of the vector space V of F. And we consider one particular example, not discuss in general. Suppose W1 is any subspace where Z belong to R. and this other W2 be the any subspace 0 y 0 such that y belongs to R. So these two are subspace of vector space V3 of R. This is the subspace of vector space V3 of R. So here, if we take the union of them, that means in W1 there are elements like this element 0 0 1, 0 0 0, 0 0 2, 0 0 minus 2 and so on. Infinite elements are there. First two elements are fixed 0 0 and third element is changing there. Third element is changing there. And if we take all elements like such elements, we found that W1 is a subspace, or W1 itself is a vector space, and it is a subspace of three-dimensional geometry. And for the W2, at the position of y coordinate, there is a element, different element, and first and last position is same, that is occur by 0. So here W1 and W2. What is the structure of W2? In W2, they are changing only this element, other element are constant. This is changeable element, other elements are constant, like this. So this is also vector space. This is also vector space, and these both are the subspace of V3 of R. V3 of R means, what is the V3 of? V3 of R means all Cartesian coordinates A, B, C, where A, B, C belongs to R, like that. So if we choose any two element, suppose we choose 0, 0, 3 element belong to W1 and 0, 2, 3 belong to W2. So these are element. So 0, 0, 3 belong to W1 and 0, 2, 3 0 only 2 belongs to W2. If we take their sum like this, so W1 plus W2, so it is 0, 2 and 3. We get this. So this element does not belongs to W1 or does not belongs to W2. So how it can possible? How can it possible? This element belonging to their union, because union is nothing but the sum. So if we add them, so we get such a type of element, but in union of W1 intersection union W2, there is no element like this element, not lies in this or this. So this set W1 plus a W2, see here, W1 plus W2 is not a subspace. Of V3 of R. So in this way, we can declare that union of two subspaces may or may not be the subspace of vector space V of M. So student, in next lecture we will discuss on some new definitions. So thank you very much. I hope you are studying, you are watching regularly all our video series. If you have any difficulties, then you can ask me through our comment box. Thank you. Thank you very much.